Okay, so let's look at some Node stuff. So I over break I went and found a kind of a pretty decent Node.js tutorial that you can follow pretty well on your own. So we'll start looking at some of that today and then branch off. But so this is from tutorials point whatever. So we'll look at this here in a few minutes. But I'm going to start off by going to the Node.js main website. This guy right here. Looks like there's two versions. We can download either latest features or this guy over here. For us, it probably does not matter. Just out of curiosity, let's see if I already have Node on here or not. I do. Okay, well. So I'm going to grab the newest one here, 5.5.0 stable. We'll just do that. So it'll download, and that should overwrite whatever I have. It's fairly small. It was only 12 megabytes. And it'll automatically choose to download whatever machine you have it on. So I'm sure there's a Linux version, a Windows version, there's a Mac version. So I'll go ahead and install this. Install for all users. Okay, fair enough. You don't have to. Yeah, it'll be on the video. You can if you want, but you probably don't need this. I grabbed the newest versions. Who knows? I might have broken something as well. But I figured I'll grab the newest one. But the stuff we're going to be using it for is pretty simple stuff. So I don't think there's really a difference between a version that was out a year ago, for instance, and something that's out today. But in any case, so I just installed Node, seemingly. So there it is on my machine. Let's see if I can see what version it is. Yep. So 5.5.0, it gave me it overrode whatever my old one was with this new, latest, greatest, coolest, whatever ist. Okay. So let's look at some of this tutorial stuff. I'm going to jump through a couple of these things here. Let me make this a little bit. Whoa. All right, so this kind of goes through some of the discussion we've already been having about, like, why do this stuff and that kind of crap. For testing Node.js just in general, we can go ahead and build a file and try to run it. So here we can choose whatever text editor we want. The file extension should be a .js file. It's JavaScript. This is their instructions for installing it, but you might as well just use the Node.js thing itself. Okay, so I'm going to go ahead and just create a file like they have here. So I'm just going to copy this. And let's go out here and let's make whatever. Let's just do a test file for right now. So I'm going to do nodetest.js. I'll open it in just the VI text editor. Go ahead and paste that stuff in here. So this is just plain Jane JavaScript console.log hello world. And then to run that, I'll go ahead and run the node test.js, and there's hello world. All right, so our first Node program. We haven't done any server crap. We literally just ran JavaScript from the command line, is what we just did. All right, So, but we got our hello world out of the way there. We ran it using Node. All right, so let's start doing some server stuff now. Okay, so I'm gonna steal this server here. We'll explain it out in code rather than read through all that stuff there. All right, so again, I have not done anything beyond what's already built into Node. I haven't brought in any third-party libraries in or anything. So right off the bat, notice I mentioned that Node does not speak HTTP without you telling it to speak HTTP. So the very first thing we're doing here is we're going to create a variable that we happen to be calling HTTP, but this could be called elephant if we wanted. But the important part is we are bringing in the HTTP functionality that comes with Node. Okay, this is not Express. We'll look at Express in a few minutes. The upgrade for Express is Express implements RESTful APIs. So Express takes HTTP and kind of puts it on steroids and lets us do endpoints. Okay, and we'll see that here in a little bit. But for right now, we're just building a simple little web server using Node.js. So again, Apache's not involved here. Nobody else, it didn't come with any other web server. We are literally writing our own web server. Okay, that's it. So HTTP, require, HTTP, whatever. So this is a variable, so we're going to use that variable to create a brand new server. And this server takes as a parameter this function that takes a request and a response. This guy right here, if we're starting to introduce some terminology, that guy is called a callback. All right. So the create server function to HTTP takes as a parameter a function. So this is something that if you've had other programming languages, let me kind of go here. Depending on which programming language world you've come from, callbacks that idea of a function being passed as a parameter to another function may or may not freak you out. Okay? If you're coming from the web world of programming, if that's your background, you've likely seen functions being passed in as parameters to other functions. Okay? And what I mean by that is if we look at this right here, in fact, actually, let me, I have Sublime on here. I do. Just for the sake of sanity, since most of you are not going to be using the VI text editor, let me go ahead and open this up in Sublime. Where did I put that? My home directory? Yep. All right. Is that big enough? Can we read that? Okay. So I just picked a different text editor here. Sublime is a pretty popular kind of a programmer's text editor. So if you are interested in it, just do a search for Sublime. It's free. Pick your poison. There's I'm going to round down and say 1 million different text editors out there for writing code. Basically, what you're looking for is something that does some auto indenting for you. I'm going to fix some of this code because I hate curly braces on that line like that. So I'll fix some of those things. But in any case, same variable right here. So we, get our HTTP. Now this is a function call. So the HTTP variable, that is whatever was returned by this require HTTP, which gives us the HTTP node module. Okay, this is the guy that knows everything about creating an HTTP server. All right, that's what that guy is. He has a function built into him called create server. All right, so I'm using HTTP to call his create server function, and this function takes in as a parameter a function. Okay? That's different if you are coming from the native programming world. Okay, if you've learned Java or C or C++ or Objective-C or C#, all of these different languages, that's not a common trend to take a function in as a parameter. All right, but in web languages, it's extremely common. And it's going to go even a step further for us because in a little bit, we're going to be looking at callback functions. So not in this case, we're saying create a server and here's our callback function. That is, when the server is created, go ahead and call this function. Okay? So this is the function that should get called whenever anybody hits our server. This would be called a callback function. All right, so the create server function takes in as a parameter the function that should get executed whenever somebody connects to our server. All right, so the function it's taking has two parameters, a request and a response. So a request tells me what they were requesting. Response is my communication channel back to allow me to respond to them. Okay, so what do I do when I get an incoming connection? Well, they're doing this whole write head thing, so it's, you know, creating, so we're writing a header out to this communication channel, setting its content type to be text./plain. This is all stuff for the benefit of a web browser. Not that important for us, but that's what we're doing. We're writing some header information about the response, and then we are spitting out hello world to the response. Okay, so everything up to this right here creates that server along with what function should get called when somebody connects to that server. That's what that says right there. Then we're telling that server to go ahead and listen on port 8081. They just randomly picked a port. You can pick your poison, pick your favorite port. All right, so you know, port 80 is probably a little bit dangerous because you might already have something listening on port 80 on your machine, but port 8081 is fine, or pick your favorite 4-digit number is acceptable enough. Okay, so this creates a server and tells that server to begin listening on port 8081. And then we're just going to spit out to the screen here after we run this that the server is running at, how does it know that that's our IP address? So anybody who's had a networking course before, what is 127.0.0.1? Huh? It's the loopback IP address. So every single TCP/IP compatible network operating system automatically has two ways of talking about itself. It has the English version, it's called localhost. Okay, and then it has an IP version, which is 127.0.0.1. Okay, this is called the loopback device. It is a non-routable IP address that always refers to the computer you're currently on. Okay, so it's saying that the server is currently running at the current machine on port 8081. Okay, now I'll go ahead and save this. That's my code is done, so I've saved it. Now before I start my server here, I just don't have to type it. I'm going to go ahead and just steal this. I'll go ahead and paste that in, press enter, and we see there's currently nothing running there. All right, so we didn't already have a server running. All I've done is written the code and saved it. I haven't run it using Node yet. Okay, so now we've proven the server's not running currently. So now let's go ahead and let's run. Oh, that was my editor. Let's run the server. So it says server is running at 127.0.0.1, port 8081. I'll go back in here, I'll hit refresh, and there's my hello world. Congratulations, we've written our first web server. All right, so that's our web server in Node.js. Still not that helpful for us, but we can see how easy that is. And this kind of goes back to what we talked about a while ago, that Node literally comes with nothing assumed. Like, okay, we're going to use Node to respond to web requests. Fine. we'll use Node to respond to web requests. All right, so we chose to do that. Now, just to give you an idea here, I'm going to go over to a second terminal window here. I'm going to choose to talk to that web server without using a web browser. So I'm going to telnet to localhost 8081. Oop, sorry. Oh, we'll probably have to do a... Did I crash it on this side? I think it's a space for telnet, not a colon like this. I expected it to spit back out here. Well, punchline is that we definitely connected to it. I just wasn't speaking the right HTTP to it. So I guess deal with it. So in any case, that's our first web server. We could talk to it from the command line here, but I wasn't speaking the right lingo. We can probably do this. Just out of curiosity, let me try. I'm going to spit the request back out. Let's see if it'll show me the HTTP that came in. It might not look like anything writing it like that. I'm not going to spend too much time on it, but that way I can mimic it from the command line. Yeah. Must be a string or a buffer, so it doesn't like that. So we'll just keep cooking on the tutorial. Not worry about it too much. Okay, so that's our first little web server thing there. And we made our request to it. Go ahead and go to the next guy. So this is kind of a built-in test bed for Node. If you just type in Node and press enter, it gives you kind of this interactive terminal so you can practice Node code, JavaScript stuff from here. I'm not going to do any of that stuff for us. We're just looking at web stuff for this. It's all part of the... Okay, so now that we're going to learn a little bit about NPM, the package manager. So again, Node comes with nothing really pre-built, okay? Or nothing pre-installed. It just has, it's like I mean, we saw when we downloaded it was 12 megabytes. Pretty small, right? So not a whole lot of stuff comes with Node. It's very, very bare bones to begin with. All right, so we have this NPM package manager that came with it. So we already have that guy accessible to us. And we want to use it to install some modules. And the module I referenced earlier is this guy called Express. All right, so we're going to go ahead and use NPM to install Express for us. So I'll go back out here. And I'm just out of the terminal, so we'll just do npm install express, press enter. It's going to do its magic, and it's talking to the powers that be up in the Node cloud, and now we have Express. Okay. These are just warnings of something I didn't set up ahead of time, but whatever. All right, so we have Express now available to us. That's all installed. All right, so now we can do things like var express equals require express. Just like we said a few minutes ago, var HTTP equals require HTTP. So HTTP came with Node. Express is built on top of HTTP to allow us to do some other cool stuff. All right. Now, one interesting thing here is we do have this idea of a global versus local installation. So where I just installed Express is actually in the local directory. So at least that was in here. So if I do an ls-l is going to give me a list of things. And one of them we're going to see in here is this thing called Node modules. This guy right here. So realistically, I probably should have done all this inside of like a directory so that we have inside our directory node test.js and then all of our modules, but I didn't, so it doesn't matter. We just have a folder here called node modules. If I go into that folder, we see we have a bunch of stuff in here, and one of the things that's in here now is Express. All right, so that's what it just installed for me. But this was a local install. So the idea of this is if you have a machine that you're working on 5 different node-based projects on, you can have 5 folders, and one folder could have these 3 packages, and another folder could have these 5 packages, and even another folder could have a similar package that's in one of the earlier folders, but it might have a newer or an older version of it if you have to be very specific about a version. All right, so this allows us to create local specific environments for an application rather than having to kind of globally create a, we might have this bloated, if we always installed everything globally, we might have this bloated node install where we have every module that we've ever used in any project we've ever screwed with installed in our system. All right, as opposed to this directory has the 5 modules that we're using for this. So this was a local install that we just did, which is the default. You can do a global install of something if you'd like, and this will just make it available by default to all node applications. So like HTTP, that module we used was globally installed before it came with Node, but we can think of that as a module that was globally installed. All right, so punchline is you probably want to have a pretty good reason to globally install something. But for us, we'll just leave it as the local install. Everybody's happy. Okay. This is just showing, for those of you who've never seen JSON, we keep referencing it, but this is node packages are represented in JSON format. So this is an example of JSON. So here's an opening JSON document. The package's name is Express. Here's the description. It's a fast, unopinionated, minimalistic web framework. Okay, whatever. Here's the version. Here's the author, contributors, license. Here's the home page. Here's the repository where you can download it. Here's all the dependencies. So these are the other projects, the other NPM things that this guy relies on. Some of those might already be installed. Some of them we might need to grab. NPM handles that for us so that we don't have to go and grab every dependency manually. It figures out what we have, what we don't have, and gets the difference. Okay. Whatever. This requires node 0.1 or newer. We're on 5.5, so we're good. Whatever. This is just all the stuff that goes into an NPM-based package. Okay, but this is an example of a JSON document. Okay, so there's nothing special about it other than it's structured. So if when we look at this, it's just a whole bunch of name-value pairs. Here's a variable name. Here's its value. Here's a variable name. Here's its value. Here's a variable name, here's its value. Here's a variable name, and its value is actually a JSON object. That's the value of the author, a JSON object. Okay, so a JSON object is a collection of name-value pairs where values can be anything, including JSON objects. Okay? Not that important for us because we're going to use pre-built libraries for parsing things like this, but just from a understanding perspective, this is what JSON looks like. Make sense? Okay. So, and again, we're not going to be writing any node packages ourselves anytime soon, but this is what they would look like if we were to write our own library and deliver it to the rest of the world. So if we, I don't know, invented something that would be handy for the node community, we could certainly create our own package and put it out there on the NPM network. Okay, so we can always uninstall a module as well if we decide we don't need it anymore. We do need it, so we're going to leave it. If there was an update to a module, we can do npm update. I think if we just do npm update in general, it'll update all of our modules that are local. Otherwise, we can tell it to update a specific module. So NPM is our go-to tool for keeping our third-party frameworks, third-party APIs completely up to date, and so that all we have to focus on is the writing our solution. Okay. Similarly, we can use NPM to search for a package. I don't think you always have to know the name. I think you can also, let me just try something here. NPM search web. This is just building a local index of all the known packages. I'll give it a maximum of 30 seconds. But I think this will show me anything that has a name that has web in it or a description that has web in it. So you can kind of browse, but realistically, the better place to browse is on the website. Just go there and search for stuff you're interested in. Oh, this is the client.
How's it going, guys? If you're doing something, you can.
No.
So I got the design for like the actual design. I don't know if you wanted me to email it to you or something.
Sure.
Okay, cool. That's all I really had to ask. I knew you were up
Okay.
here, so.
Yep. Yeah. So email it, and then I can send it out to them because that's what we're working on in class. So, yeah, we're doing an introduction to something called Node.js. That's going to be our server backend.
Cool.
So, yeah. So this is Dominic. He's the guy with the idea for the snow removal and the lawn mowing dealie. So we've been spending our time working on this, and now we're actually starting to code.
Cool. I'm glad you guys got the good brains. I used to code. It's too hard now. Way back in the day.
All right. So as we see here, I did a search, and it brought up anything that had the word web in it. All right. So probably not the best way to digest NPM, but you could if you wanted to. Otherwise, you can just go to the website and probably a little bit better search tools there. All right, so this is all about creating your own module. We're not going to do that. Did it do an Express example yet? Oh, they just showed NPM there. Express example comes later. All right, so this is talking about callback concept. We just sort of talked about it here. So I probably won't do this example, but let's just talk about it here. So we talked earlier about asynchronous versus synchronous. So what they're doing here, they're looking at a blocking code example. So that is something where we do something and it prevents other things from happening. Let's just do it. Let's just run this. So just so we see how this works, I'm going to go ahead and steal that code. We'll paste it in here because we're going to be changing our server anyway, so it's not the end of the world. All right, so this is requiring a built-in node thing called FS for the file system, so we're going to be talking about a local file. All right, and it's going to try to read in a file called input.txt from the local file system. This will just sit locally right there. So, and it's doing this read as a synchronous read, okay, which means it does block. So we will not get to this line until after this has completed. All right, that's considered blocking. All right, so blocking says this line sits and stalls until it's done reading in that text file. All right, so we need to create a file called input.txt first just to make this work. So what I'm going to do, is this going to be fast now? Not that fast. All right, so let's just do... All right, so I created a file called input.txt, and right now input.txt is actually just the, this is what it looks like. It's an output of my directory. All right, so I just did a directory listing and redirected the output to that file, so now my file is just filled up with this list of all the crap in this directory. Okay? But important thing for us is we now have a file called input.txt. All right, so I'm going to go ahead and run our program, node test. And before I actually press enter on it, what we should see here is it's going to create the file system. We won't actually see that. It'll use the file system to read this file, input.txt, into a variable called data. And then we're going to output data to the screen, and then we're going to say program ended. All right. Now, realistically, we may not notice that there's a pause here because reading in a file is going to feel pretty quick to us. All right, but this will all happen in this order. Read in file, write contents of file out to the screen, write program ended to the screen. Okay? So there's my contents of my file is this giant list here, and then program ended at the very end. Fair enough? That's the order in which it happened. Now, the next example I assume is going to be an asynchronous. Here's a non-blocking example. So here I'll just steal this and we'll walk through the code. Okay, again, same file system library. We're going to use that file system to read a file. Now notice that by default, the node way of doing things is asynchronous. We had to specify we wanted to do that other thing synchronously. All right, so we're just doing the normal plain Jane read file. We're reading a file called input.txt. Here's the callback function. All right, so this says read in this file, and when you're done, pass the information to this function. So this function takes in two parameters, a potential error, and then the data that was read in. And what are we going to do? We're going to say, well, if there was an error, let's go ahead and here I'm going to rewrite this a little bit in human readable code. One thing that I'm kind of nitpicky about with programmers is so often programmers try to make things look shorter at the cost of being harder to read. So we'll try to read in the file. Here's the name of the file. Here's the function I want you to call. It takes in two parameters, error and data. If there is an error, that's what this says. If error has something in it, go ahead and return whatever comes out from console.error. So we're writing stuff out to standard error. So for those of you in 450, this will output to standard error, which is different than standard output. This is that second output stream we talked about. That's a systems programming concept. All right, so if we have an error, print out the error. Otherwise, let's just go ahead and this also returns. So return makes a function immediately end. So we'll never get down here if we get inside this if statement. Otherwise, let's just print out our data. Now, because we're reading this file asynchronously, the order that we're going to see stuff spit out in is actually going to be program ended first. Then, probably a fraction of a second later, is when this function will actually get called back because we finished reading it in from the file system. Therefore, that data is now available and we'll write the data out. Okay, and that's because this was an asynchronous call. This did not block. So when we said read this file, it did not prevent us from getting to this next line. It did not block us from getting to that next line. That make sense? That's the difference between blocking and non-blocking communication. Same end, but a little bit different means. All right, so here's our output, but we noticed that the program ended before we outputted the stuff. Make sense? All right, and I was confident it was going to win that race because it literally did not block, and there was going to be enough time in there that it was going to have to call back that callback function. So 100% of the time, you would get this output from it. That function would never win the race of it automatically moving on to the next line. Part of that is because to do this asynchronously actually requires this function to spawn off another thread in the background to go and do some extra work to read in this file and stuff like that. And all of that takes up some CPU cycles, takes up time. Okay, so he would have never won that race. So we'll always have this line print out first. All right, now, having said that, the disadvantage, this is something we talked about earlier, is when I was right here, if I wanted to print out the data from that file right here, I don't have it. Okay, I don't get the data from that file until the callback function is actually called, passing it that data. But since this guy does not block, I automatically move on to this line. So if I'm reliant on that data being available to me when I get to this line, I better make that previous call synchronously. That makes sense? So we don't want to have this idea that asynchronous is always better than synchronous. Okay, it's the right tool for the job is what we're looking for. Okay? All right, so that's a non-blocking code example. Okay, so one of the other things Node brings to the table is this idea of event-driven programming. Okay, so we can, and this is similar to that asynchronous thing, but it kind of goes the other direction. So for example, what we just saw here is in that previous little example, back here, we saw us try to read in a file from the local operating system, and then it notified us when it was done. Now, what if I want to be on the other end of that coin? What if I want to move on with life and I want to be notified when data is available or something like that for an event that I started? Okay, instead of me asking somebody else to read in text, what if somebody else asked me to do something and then I need to then be aware if there's something else I need to respond to? So I need to be able to respond to my own events. All right, so Node has built-in facilities for doing this. It'll be interesting to see what their example is. Oh, okay, they just created an emitter, that's fine. All right, so here's the example. Let's just steal it and we'll walk through it. Okay, so we're grabbing a variable up here called events, and this is going to bring in this package called events, and then I'm going to have this thing called an event emitter. It's going to bring in it's going to create a event emitter from our events package. Okay, so this guy can't exist until this guy already is created. All right, then we're going to create this connection handler thing. Okay, and this is just a variable called connect handler that's equal to a function. All right, so this is no different than functions in your native languages you're used to, except usually part of the syntax for creating a function has the name in it. Where in JavaScript, we've already seen, we can actually pass functions in as parameters to other functions. Therefore, functions do not require a name. Okay, for those of you who've had programming language theory, what are functions that don't have names? Okay, anonymous functions is okay, but I'm just for 470 guys. What's an unnamed function? Lambda. All right, so we're seeing that in practice now in a real programming language. Right? This guy here is a lambda. We're naming it connect handler so that we have a way of accessing it later on. Same thing in Scheme when we said define whatever to be equal to lambda, blah, blah, blah. All right, so in languages like C, C++, Java, C#, we can't do that. The name of a function comes with the definition of a function. Those are glued together. You can't have one without the other. In these more modern languages that follow, let's call it the web way of doing things, but really it's maybe the more general purpose or more flexible programming paradigm disconnects the idea of a variable from a function. And now we can choose whether or not we want to name our functions or not, as opposed to sometimes we're just going to pass a function in as a parameter and say, hey, whenever you're done, just call this guy. All right, but in this case, we're going to store the function. So here's our function. We're going to store it inside of connect handler. So the function is called connected. And this guy is going to just spit out connection successful. All right, so this is going to be our connect handler. Then we're going to use our event emitter. Oh, this is actually still inside the function. Let me kick this down. So we'll go ahead and when there is a connection, we'll go ahead and say spit out to the screen connection successful. Then we'll use our event emitter that we created above to go ahead and just spit out, raise an event called data received, whatever that means. All right. So kind of like raising the flag. So we're raising an event called data received. All right. This is what we do as a response to a connection. All right. Now we're using our event emitter here to respond to connections. So notice here, event emitter dot on. So this is the event we're interested in. So on an incoming connection, go ahead and call the connect handler. So whenever there's a connection, what do? We call our connect handler. What does our connect handler do? It spits out connection successful and then raises the data received event. Event emitter on data received. So whenever we see the data received event, what do? Well, we do whatever this function does. So this function takes in no parameters, so this would be an unnamed function. So that's a lambda, okay? Or you call it an anonymous function, that's fine. So this is a function, takes no parameters, and what does this guy do? Let me reformat this so it doesn't make me nauseous. All right, so on data received, we have a function. This guy's going to just output data received successfully. So what do we do down here since we didn't actually build a server here? This gets the ball rolling. So we emit our initial event of connection, which then fires the on connection, which calls the connect handler, which says connection successful, which emits the data received, which calls this event here, which says data received successfully, and then we see program ended. All right, so this is all about these two on things here. These guys are passively awaiting those events. And whenever those events get raised, those guys fire. Okay, this is another kind of unique feature of Node. It's this idea of event handling like this. These are asynchronous events. So the very first thing our program does is it emits. This is the hard-coded emit. So our program just says, okay, well, I need to get the ball rolling, so connection. All right, and as soon as that happens, this guy notices. And when this guy notices that event, he calls the handler for that event, which is this function up here. And at the end of that function up here, that guy says, data received. He throws that up there, okay, raises another event. And this guy happens to notice that data was received. So he calls this function, which just prints out data received, which does not emit anything else. All right, so this program should print out connection successful, then emit a new thing, which then is going to call data received successfully, this guy. So then the question is when does program ended show up? Well, what do you think it'll be? What's your best guess and why?
If you have to specify for something to be synchronous, then my guess is that by default.
Yeah, so it seems to be that the Node way of doing things is it's asynchronous unless otherwise told. Okay, so that would lead us to believe that this event emitter will emit this event. Fine, that's going to get that ball rolling, right? And then these guys, with some probably minor delay, become aware of those events. But we would expect that this line does not block this line. That would be our suspicion, right? So the very first thing we would expect to see is program ended. And then the rest of this kind of, I guess the result of the pinball game will play out. All right, so let's go ahead and save this. Whoop. That's a Sublime thing. You never have to pay for Sublime as long as you're willing to sometimes hit cancel. Just FYI. So let's run that. Was it asynchronous? Program ended was at the end.
Maybe when we use event handlers, those will be in synchronous mode.
Well, so if we go back to the code here, it's not so much the event handlers. What line here can we say was synchronous? That was a synchronous line, was it? Why do you think that is? Well, I mean, we know it's a synchronous line because this guy printed out last. So all the other crap up here, that pinball game, happened before we ever got past this line. So this guy must be a synchronous call. But we speculated that because this is Node, and Node is the master of asynchronous communication, that this must be asynchronous. But we just saw it's not. Why do you think that a call to emit from an event emitter is a synchronous call? This gets back to this idea of right tool for the job. Why might we want to emit an event? I mean, what's the purpose? I mean, fine, we're running a little stupid example here, right, just to kind of learn this stuff, but what's the purpose of emitting an event? What might I be trying to accomplish?
Some kind of actions to be taken to prevent the transaction. Those to be put on.
Okay,
In the events.
well,
In any transaction, some events will automatically generate with respect to triggers.
I'm going to actually do something else here. I have two separate on data receives in here. One of them calls this function, the other one calls this function. I'm going to go ahead and run this guy again. So notice that data received successfully, and the other guy got called too. I was also interested. So I had two separate dudes interested in when data was received. So they had two separate actions I wanted to do. They just happened to both be spitting some stupid text out, but I could have done something different, right? Okay, but this is kind of the Node way of doing things. So now, going back to my question, when we raise an event, when we emit an event, we're doing it to notify others of something occurring. Might we want to give those guys a chance to respond before we just move on? It kind of makes sense, right? Why raise the event if we're not going to give them a chance to do their thing, right? Especially, what if the very next line was, what if this was inside of a function, let's say, and the very next line was return, right? It literally killed off the function. Like, oh, you got to catch me from in the middle of your, raising your event. You just you killed off the function. You moved on. You ran out the door and locked it or something. All right. So in this case, it makes logical sense for the event emitter to be blocking, to be synchronous. All right. So what did that teach us? That teaches us this idea that Node, while it might try to choose asynchronous by default when it makes sense, we can't just assume that everything's asynchronous because some things it doesn't make sense. It really would never make sense for an emit function to be asynchronous because of its nature. The problem we're solving here is to let others know about something. Okay, therefore, we have to finish screaming and let that kind of propagate among all the dudes who might be interested before we move on. That makes sense? We want to make sure our message was delivered before we move on. Okay? So event emitter is a synchronous call. It's not all that important that we memorize those things. Maybe the thing I want you to get out of this is that at the very least, let something pass through your brain in terms of how you suspect it will work, knowing that sometimes you won't think about it right. Okay? I mean, her suggestion that this was asynchronous was 100% reasonable, given what we've talked about so far. Now we explored it, we saw, okay, well, it worked a little different. Now we asked the question why, and now it kind of makes sense. All right? So 2 things here that are pretty important. First of all, when you're writing code, test often. Don't create an entire huge solution based on an assumption. If you're not 100% sure about how something might work, test it like this. Make sure you understand how it works so that your solution is based on reality, not an assumption. Because 500 lines of code later, you might find this fairly tricky to debug if something that you assume to work one way actually does not work that way. All right. So that is event handling, I think was this section, right? Yeah, the event loop. All right, so this idea of event emitters, raising events and being able to respond to specific events. All right, so that's kind of a tool in our toolbox now that might be handy for us. Okay, let's see. Just gotta give us a sample code here. All right, that's fine. Let's look at this. This is kind of showing you a more object-oriented approach to, oh, do I have the skills? To event emitters. Kind of what I was talking about a few minutes ago, where what if something was inside of a function. So again, we're going to have our events. Again, we're going to have our event emitter. We're going to create a couple of different listeners. So we have this listener 1, which just says listener 1 executed. Right, so this is that idea that you can have multiple listeners. So this is just a function, and this guy just spits out who he is and says he was executed. Here's another function, says who he is and that he was executed. Then we're going to go ahead and add, use our event emitter to add a new listener. All right, and we're going to add a listener for connection. And the listener we're going to create is this guy, listener 1. Right, so we've built in, this is an event that might happen. So here's 2 different ways of binding an event listener. On one hand, we can tell the event emitter in general to add a listener for this specific event. And here's the listener. On the other hand, we can say, respond on this event with this listener. These 2 guys effectively pull off the same thing. Make sense? All right. All right, so now we have a variable called event listeners. So this is going to require events. We're going to go ahead and get an event emitter. We're going to get a listener count from our event emitter on connection. All right, so this is going to show us all of the dudes. This is going to build for us a list of event listeners. Everybody who's interested in this event, which in this case should be 2 people. Listener 1, listener 2. Those are the 2 guys that have been associated with the connection event. All right, so this scary line here just goes through and finds all of the listeners for this event. All right, then we're printing out those listeners, and then we just say, these are the listeners for the listening to connection event. All right, so we should see 2 guys there. So all of this stuff is happening before an event was actually raised. So this is kind of proof of setup. So when we see these couple of guys right here, this is saying, okay, we've done some work right here. We created a couple of listeners. We associated those listeners with the same event in 2 different ways. And now let's prove that that worked by printing out all the listeners that are associated with connection. Right? Then we're going to actually fire that connection and actually see it happen. So this will emit connection. So we should see listener 1 executed, listener 2 executed. Then we'll remove listener 1 from connection and then spit out to the screen that this guy's no longer interested in that event. All right? Then we'll emit the event again, noticing that listener 1 no longer gets executed because he's been dropped from the interest list. All right, so now this guy will fire listener 2 executed. All right, and then we will print out all of our event listeners again, which should show just the one that's associated with the connection thing, and then we'll see program ended. Okay, so here's our 2 listeners proving the setup. Then we emitted it. Here's our 2 guys responding. Then we disabled listener 1, said he's no longer interested in that. Then we emitted it again, seeing only listener 2 was interested. Then we proved it by saying who's interested in that connection event, only 1 listener. And then program ended. That make sense? So let me go back here. I think we talked about it up here somewhere. There we go. So last time we talked about this idea of design patterns. Okay? And specifically we talked about MVC, Model View Controller, the idea of separating our code from our interface, right? Now, I didn't talk about additional design patterns in here yet, but some of you who've had me for other classes have heard me talk about other design patterns. This idea of our event emitter, what design pattern does that sound like it's implementing? When I teach design patterns, I usually introduce 3 design patterns. Right? I introduce MVC, I introduce singleton, and what's the other one I introduce? The observer design pattern. Okay. This emitter thing is an implementation of the observer design pattern. The observer design pattern says it's a good idea, if you're interested in an event, to not stand around and wait for it to occur. Instead, be productive and then become notified when the event you're interested in finally fires. That's what the observer design pattern says. Okay? Just like MVC says, it's a good idea to separate your code from your interface. Okay, the other one's the singleton that says it's a good idea if you have stuff you need to share between multiple objects, for example, keep it all in one place rather than pass it around to 30 different spots. All right, so what we just saw here is an example of the observer design pattern. And we can imagine it being fairly helpful, right? You know, we have various, well, in this case we're looking at it in a single file, but you know, if we kind of imagine there might be various aspects of our application that might all be interested in the same event and might respond differently depending on that event, right? So, for example, for us, let's say that a user requests some new a service. Okay, so we have on user request. All right, now on that we might have one guy that goes ahead and maybe associates in our database with that user that he has a request. We might have a separate function that's also interested in that, and maybe he does the job of figuring out which of our service providers should we associate this request with based on location. So at the very least we have two guys interested in a user request, a service request event, right? Both of those things could happen. We should probably raise that event when that endpoint is called. All right, because we want to handle it. We want to handle the same event in multiple ways, is the punchline. We might as well take advantage of the asynchronous nature of Node, and rather than linearly doing it, where we say, okay, well, let's write to the database first, then let's figure out who we should send this message to. Why don't you just handle it as 2 separate events and say, well, this guy's in charge of writing to database. That's what he does. He writes to the database. That keeps that function nice and compact, and it's very clear what it does. And then this guy's in charge of figuring out of our 5,000 service providers, which ones are within a 20-mile radius of the service that's being performed. That type of thing. All right, so we kind of understand maybe the use of these event emitters, how they can come in handy. All right, so all right, buffers. Hopefully this example is a decent one because okay, so first of all, we're not using any built-in modules for this one. So we're creating a new variable called a buffer. Well, it's called buff, and it's of type buffer, capable of holding 26 things. All right, we're going to go ahead and we're going to spin through. This loop goes through 0 to 25. So it addresses each element of this buffer. So think of a buffer as like an array, okay, a collection of stuff. And what is it going to do each time through? It's going to, so I is going to be 0 the first time, then 1 the next time, then 2 the next time, so on and so forth. It'll set buff at bucket 0 equal to 0 plus 97. Then 1 plus 97, 2 plus 97. So the ASCII values for, this is I think the lowercase alphabet. So if you looked up at an ASCII table, you would see that 97 is a lowercase a, 98 is a lowercase b, 99 is lowercase c, so on and so forth. All right, so we're filling up this buffer with the integer values that map to ASCII characters. Make sense? That's what this guy does. So when this loop is done, buff is filled up with the integer representation for the ASCII characters A through Z, lowercase. All right, so now we're going to write some stuff out. First thing we're going to do is we're going to take our buffer, we're going to convert it to a string and tell it, treat this guy as the ASCII format. So this should show us A through Z, all the letters in the alphabet. Okay? Because it's going to do that mapping for us because we've specifically told it to do the ASCII mapping for us. It converts that 97 to a lowercase a, the 98 to a lowercase b, that kind of stuff. All right, now here's another one. We're going to convert that buffer to a string because it's not a string by default, it's a collection type. So we'll create that buffer to a string and we'll say only give me the first 0 to 5, 0 to 5 inclusive, non-inclusive. A, B, C, D, E. Yeah, this is non-inclusive. So this would be 0, 1, 2, 3, and 4 from the positions in ASCII. Oh, it tells us the opposite. So this would be A, B, C, D, E. Then we have console log, toString. This is UTF-8, so it's a different character map. Okay, different character map. And this guy is a superset of ASCII. Okay, so this is going to be Unicode. Still 0 through 5, but Unicode is a superset of ASCII, meaning the first 256 characters of Unicode is identical to the first 256 characters, well, to all the characters of ASCII, which has 256 characters in it. All right, next one, we're going to take our buffer to string, and we do not define the character encoding we want it to use. Okay? It still outputs A, B, C, D, E because we see that the default character encoding in Node is Unicode, UTF-8. All right, so this is kind of showing us how character encodings happen, and buffers are different than lists. Okay, these guys would be considered higher performance, how we go through these. So that's why we have these convenience things to convert these guys back to strings. All right. Run this real quick just as part of the exercise and move on with life. All right, so that's that guy. Notice we can also tell a buffer to convert itself to JSON. just like that. So here is a JSON representation of that buffer. So the type is buffer. The data variable, its value is an array of literals, 97, 98, 99, so on and so forth. Make sense? So JSON is built into Node. You're not going to find that in PHP. You're not going to find that in Ruby. You'll sort of find that in Python through a third party. But all those other guys have third parties that will do JSON. But just more evidence that JSON is very much an integral part of this guy. Okay. So you can concatenate buffers together, whatever. All interesting stuff, but not all that interesting for us. So that whole buffer section is, if you want to deal with collections of things and compare them with other things, that's a good place to look. All right, streams. This is a unique thing with Node, so let's look at this guy. So this is kind of bringing a couple of things together that we talked about today. So things that have callbacks associated with them along with event emitters. Okay, but in this case, instead of us actually raising the events, somebody else is raising the events, and we're becoming aware of it here. Oh, I zigged when I should have zagged. All right, so we've already seen this. This gives us access to our file system. Here's a variable called data that we start off as empty. Probably gives us the idea that we're probably going to be filling it as we can. Okay. Then we're going to go ahead and we're going to create a reader stream. Well, that's just the name of the variable. Specifically, we're using our file system to ask for a reader stream. And we're going to read from the same file we created before, input.txt. All right, so we'll be able to utilize that guy. So this is going to create this special kind of thing called a stream that will read in from this guy. Okay, we can set the encoding for that stream. I suspect that this is a redundant line. The encoding probably is by default UTF-8. Having said that, good programming practice would say never rely on default values. So if you want to make sure it's a Unicode encoding, make it a Unicode encoding. All right, so that's what that guy's doing. So it's saying, treat this stream as you read from it, read characters out of it, text characters out of it. Okay, so now this stream has been created, but we haven't said read or anything like that. The stream is kind of doing its thing, so to speak. So we create some event listeners. So here's our stream. Whenever data arrives, we're going to have a function that's going to, we just happen to name this variable chunk, but that's a chunk of data, okay? So we'll take that chunk of data, and what are we going to do? We're going to tack it on to our variable called data. So we're going to concatenate the chunk onto data. Every single time we get some data, we concatenate on the chunk. Okay, and I'm going to kind of add some stuff to this a little bit. So I'm going to say console.log receive data. And we should see that this guy gets called multiple times, because we don't read that file in all at once. We stream it in, whether it's a byte or several bytes at a time, depending on how the underlying file system works. But we should see receive data print out multiple times as we're building up our data one chunk at a time, or sub-chunks at a time. It maybe sounds gross, but whatever. All right, so similarly, we also have another listener on end. So whenever we're done streaming in bytes from that file, this guy will get called and will actually spit out our file there. The contents, everything that we've collected. All right? And then we also have another guy on error. So if something bad happens, let's just print out the bad stuff. So this prints out a stack trace of the error and will tell us what funky stuff happened. All right, then we have our program ended. So we should see receive data ... multiple times as it's accumulating data, and then we should see our actual data, and then we should see program ended. But actually, let me ask you this. We'll make another guess at this. Will I see program ended first? Or will I see program ended last? Before, we saw that when we emitted an event, it was blocking. But in this case, we're not emitting events, are we? We're responding to events. We're listening for events, but we're not emitting them. So do you suspect that we'll see program ended first or program ended last? Which makes the most sense? You think last? How long might it be before a event is emitted? We don't know. How would we know when the last event is emitted? Excuse me. So again, we're trying to figure out how it should work. How many times? Oh, well, that's true. When we hear end, we know it's over. Or error, it's over. But do we know how long that'll be? We don't. Does anything here indicate that we're quitting the program or anything like that? Or responding to that event is just a print? Just printing some stuff out, right? So the question is, if this is a running program, and we set up these listeners that are interested in these events, and this is what they do, when does this program actually decide to end? At what point has it concluded that no more events will be arriving? You're assuming, but is my response to end anything special? It's just a print statement, right? Okay, so your suspicion is maybe this end thing has semantics associated with it. There's a deeper meaning to end, which actually then releases the program to finish. It's kind of your suspicion, right? All right, let's take a look. Program ended right off the bat. All right, so we set up these listeners, and these listeners are sitting there running asynchronously in the background, and our program was allowed to finish. We did everything we needed to do. We set some listeners up, we passed in the functions that are associated with those listeners, and said, hey, whenever you receive some crap, call these functions. My job is done. Why should I hang out when I don't have anything else to do? Now, what was interesting here is that we received all the data in one fell chunk. I expected it to be in multiples, so the size of our data probably just needs to be bigger. Let's see, can I force that? I think we can force that. Oh, I don't think that's output for my program. I think that's total number of files. That's inside of input. that's in my file. Yeah, just when I thought my voice was better. Well, at least I'm not in pain. Last week it hurt. Okay, so kind of makes sense. Again, we're seeing this. Was that phrasing? Was it? Is it bad? I'm always getting teased about accidental phrasing or something. It was bad. No, whatever. All right. So let's go back. So this was us responding to events that we don't have control over. So it kind of makes sense that our program should be, when we say program ended, we're trying, we're kind of converting that into this thing. What we're really saying here is that we're done doing what we need to do here. So that's what we output it. We've done all of our setup, and now this thing is still alive. So when we say program ended, it hasn't really stopped running. We just have finished all of our stuff we wrote for it. Say this again. It didn't console log the word data. It console logged the contents of the variable data. Yep. So that was my big wall of text. All right. So here's a writing to a stream. So file system. Here's our data we want to write. Simply easy learning, whatever. Here's our writer stream. So we'll use our file system to create a write stream to this file called output.txt. We'll write our data in that format, and then we'll end our write stream. And then we have our handler events. So when write stream finishes, we can go ahead and just output write completed. If there's an error, we'll do something else, whatever. All right, pretty self-explanatory, I think. All right, so this is where things maybe get a little bit more interesting. So I'm going to copy this guy. All right, so here we have our file system again. And we're going to create our reader stream, same thing we did before. So here's our ability to read in from a file. And then we're going to create our writer stream, the ability to write out to a file, but these are streams. All right. So this is not using the default I/O system. This is using this node version of a stream, which brings things in. Think of it like flowing water. All right. So we could potentially deal with things in pieces. So my data wasn't big enough in that last example to see that on data would get called multiple times if there was enough data, but it would. Trust me, it would. Okay, but what we're doing here is we're actually utilizing something called a pipe, which we've talked about in the 450 class as well. And that is this idea of we're going to take our reader stream and we're going to pipe. Instead of it going into some variable, emitting events and things like that, instead we're going to connect it to our writer stream's events and let our writer stream handle all those emitted events coming from our reader stream. So we've now connected these two guys together. The program will have ended here, and then if we go and check output.txt, we should see that it's filled up with that code. So if I run this, I'll clear the screen here real quick. We don't have any real output there, but if I do more output.txt, we see this guy's been created and it has the contents of the other stuff. All right, so that's piping output from one thing to another. File I/O really isn't all that common to do anymore, but well, this is actually kind of a cool one though. So we can chain streams together using some built-in stuff. So we're going to get two libraries, or two modules that are built in. Our file system one again, and then we have the zlib. So this is a compression library for zipping up files. All right, so we're going to create a read stream, input text. We're going to pipe that to our zlib create gzip. So it has a function that knows how to take a stream of data and compress it. All right. Then we're going to pipe the output of that into our write stream, which is going to write out to a file called input.txt.gz, which will be a compressed version of our input.txt file. And we didn't do any magic with the compression. We just used this tool that was provided to us. It was laying on the shelf. So we grabbed the compression tool. We said, all right, we're going to throw a data stream at you. You do what you do. And in the end, we then piped it to a new output file that we just happened to name text.gz, so that, you know, if to a person looking at it, we would believe that that's a zipped up file. So this is us chaining multiple streams together. So punchline here is that you could pipe multiple things together. Streams allow us to redirect data from one point to another, that kind of stuff. All right, so file compressed. And actually, if you go back and look at this code, oh, yeah, we said the file compressed here. So now we should have a more input.gz. So if I press enter on this, it probably is going to look like wonky binary-ish type stuff. So maybe a binary file. Do you want to see it anyway? Sure, let's ruin the screen. So there we go. All right, so that's the output of the gzip library on that. So proving that it went through that library and now it's compressed. All right. Similarly, we can uncompress it here if we wanted to, but let's not beat the dead horse. I want to get to the Express framework here. All right, synchronous versus asynchronous. I think we've dealt with that, right? Oh man, good thing we dealt with that. Oh, it's just some global objects that are part of Node. We'll come back to this if we need these things, like what the local directory is and timeouts and stuff like that. More utility stuff built into the OS in case we need, here's some system functions, where we are in the system, some networking stuff, DNS stuff, domain stuff we likely won't need, but just this tutorial covers it. Okay, so this is kind of what we've been talking about today, is this idea of a web server, that kind of stuff. And in this case, they're creating a, I guess, a relatively, here, let's just walk this real quick. This is kind of leading us up to Express. So we already created a web server before. So now what we can do is when we receive a request, we can get the URL of that request, and so that we can print out what we got. We can read that file in. We can actually parse it into the HTML, parse it into HTML, and do all this stuff. Effectively, that's what a web server does, right? Receives requests and writes stuff back out to HTML. So down here, they're showing. If we create this file and we run this, it will serve this HTML file back to the web browser. So this will be pretty similar to the thing we wrote a little bit ago, with the exception that instead of it just saying hello world on the screen, it's actually creating an HTML formatted document with the title of it being sample page, and the hello world actually won't look any different because they didn't format it like in bold or anything, but we'll see that this guy effectively does what a traditional web server does, and that is it handles a request for a file name. It goes and looks up that file. In this case, the file will be index.htm. It'll grab that file, which already has HTML code in it, and it serves it back to the browser. This is how web servers work. Okay, these are all things we've talked about at the high level. Similarly, we could build our own web client using Node. So if we choose not to use the web browser and we want to have our own web client do this, so this guy is going to use HTTP, but he's going to use the client side of HTTP. All right, so the host is going to be localhost, the port's going to be 8081, the path is going to be index.html. So this is just creating a collection of those values. This is a dictionary is the type of object that is. So here's our callbacks, and when we receive the response, here's our body. So we're going to, on data, go ahead and just tack stuff onto the body. So as we receive the response from our stream, we're going to build up this variable called body. In the end, we'll print out the body that we received. So this is just kind of putting all the things together that we've looked at. And then at the very end, we'll go ahead and we'll make our request by making a request to HTTP, giving it our options, giving it the callback function that we wanted to do, and then we'll end that request. So this guy relies on that server being running. So we'll have our server running on one screen and then go open another terminal window and launch our client to talk to that server. So this guy does basically what our web browser does already. All right, but we want to get to the Express stuff. So here's the output of that client. So this is what a web browser would have received. And a web browser would view this as HTML and turn it into, no pictures in this case, but I always say pretty pictures and text. Whereas the client here didn't know how to deal with HTML, you just spit it out to the screen. All right, Express framework. All right, so it wants us to install a couple things. So we already installed Express, and then it wants us to save it. Saving it, I'm having a brain fart here. Save, I think, means that when you run an npm update, I feel like I'm about to lie to you. Maybe save is the default anyways, because we were doing a local thing anyways. For right now, I'm going to say I don't know. It's a void. My brain is missing it, so I don't want to lie to you. So it does something. We already have Express installed. Now we're going to go ahead and install body parser, cookie parser, and Molter. So there's body parser. Here's cookie parser. And here's Molter. All right, so now here's our sample Express server. All right, so we'll go ahead and require Express. Here's our app. So this creates our Express server. Okay, now this is where I'm talking about endpoints. All right, so earlier we talked about gets and posts and puts and deletes. So we're telling app to create an endpoint of type get. And that endpoint is going to be /. And here's the callback function, request response, and it should spit back hello world. Similarly, I'm going to just steal this and create a second one just so we can compress this since we're getting a little low on time here. There we go. All right, so I have two separate endpoints in my program. / gives me hello world. /smile spits back the smile thing. Okay? So each of these are endpoints. Now imagine if we start expanding this out to our actual application, we're going to have an endpoint for give me all the requested things. Maybe an endpoint for login. Maybe an endpoint for accept job. Things like that. So we'll have endpoints for these different things. So now here's our server. So var server is app.listen on 8081. So this is an abstraction of what we did earlier. Earlier we were using the built-in HTTP module. Now we're using Express, which makes that guy kind of easier to use, but also allows us to build RESTful APIs. That's effectively what we're doing here, except we're only using GET requests right now. So we'll tell the app to listen on 8081. Here's the function. So this guy will get a host and a port, and then it'll tell us it's listening on that. So these two values, the host will be localhost, port will be 8081. Localhost, this might be 127.0.0.1, but I bet you it's localhost. So we'll save this. Go ahead and run our server. Actually, that's interesting. It was actually nothing. All right, so it should be listening now. Let's go into our browser here. I'll put our default endpoint there. That's hello world /smile. There's our smile. All right, so see how easy it was to handle multiple endpoints like that? All right, so I mean, this is where Node starts shining, is the ability for us to have, I mean, this is even by a beginning programmer's perspective, this isn't a whole lot of code, right? You said you haven't had any programming. This isn't like that intimidating, right? And we just wrote a web server that handled 2 different endpoints. So this is effectively Apache. So that's we just wrote Apache. It's 21 lines. We're good. All right. So let's kind of see where this is going next. All right, because we definitely want to start messing with request response and routing. Okay, yeah, so notice here, now they're going to start doing some posts and deletes. So now we're seeing them starting to expand on that idea of the HTTP protocol. All right, so why don't we just, because we're kind of dead, I won't talk about the assignment here real quick. We'll pick up here next time. So somebody remind me that we were on the Express framework page, dealy, flippy. I'll probably remember, but just in case. We'll keep going from here and start building it out, but we'll also talk about our homework assignment. So, and if you will you just email me tomorrow? I'll give you the other assignment. I think it'll be more productive for you. Is that cool? And anybody else in here who feels like they're weak on programming, you can email me as well, and I'll give you that alternative assignment. But if you feel like you have a decent background in programming, I'd rather you do this assignment. Okay, but I want him to have a good experience and not regret taking the course. Okay, so let's see where we at here. Okay, so I made this one a 20 to 25 page paper. It doesn't matter. You're just going to pick Node.js. All right, no, it's so we're looking at various cloud computing or database options. So some of these things have come up. So I want you to research a product called Firebase, which I found is similar to Parse. So let's look into that. Amazon Web Services, which we referenced today, which is our IaaS. Google App Engine, which is a PaaS. And then MongoDB, which you've mentioned quite a bit. MongoDB effectively is a wrapper for an existing database management system. So, and the one thing I say here is, so let me just keep reading this and I'll circle back on this. So MongoDB is a possible storage solution for our application. You can assume that we'll be hosting our Node.js server on Heroku. So you can make your comparisons with that in mind. So I'll write a 3 to 5 page paper. It could be double spaced, all that stuff. comparing these solutions and ultimately making a recommendation to which technology is most appropriate for our project. So what I was trying to get at there with MongoDB is that MongoDB does not specify the underlying database. MongoDB provides a interface into a database to make life easier for us to communicate with it. So for example, Node.js has a MongoDB NPM, has a module that knows how to talk to a database using MongoDB. Now, having said that, it's worth considering that instead of using one of these third-party solutions, like historically some of the CS guys have done, it's worth at least talking about that, because since we're going to be hosting this on Heroku, and Heroku supports various databases, whether it's PostgreSQL or MySQL, I think it at least supports those too. MongoDB is compatible with both of those. So now we have to make that decision. Do we keep all of our backend server and data on Heroku, or do we bring a third-party choice into this? And where it becomes less of a clean-cut answer is what we're going to have to discuss next time is, how does our iPhone talk to this database? Does our iPhone talk to the database directly when it can, or does our iPhone always talk to the database through our Node.js server? That makes sense? That's a decision we're going to have to think about. We're going to have to think about the ramifications of, or the difficulties, let's say, of having an iPhone app talk to a Node.js server. Shouldn't be bad, but that's kind of what you're looking at with this project. Okay. Questions, comments, concerns, bribes? All right. I will see everybody next Monday, and I'll look for your email tomorrow. Sound good?